Okay, welcome to Limiting Reactant Stoichiometry Problems, worksheet number 1. You will want a periodic table and a calculator in front of you to get through this. Let's go over a few things really fast. We know that the limiting reactant controls the stoichiometry. It's not always the smallest number of moles. It's the one that does not satisfy the ratio. We also know that solid, pure, liquid, pure gas, we do moles equal mass over formula weight. We know if we have a solution, we do moles equal molarity times volume in liters. And we know if we have a gas, we do moles equal volume in liters over 22.4. With all that understanding, we're going to take a look at this. And per usual, if you think you can do it, my suggestion is to start to try it yourself and then pause the program and see how far you can get, and then always come back if you need more help. All right, so we're looking here first. First step to any good stoichiometry problem is to check and see if it's balanced. Check and see if this question is balanced. The answer to that is yes, it is balanced. So now we're just going to read. Kind of a couple tips that you know it's going to be a limiting access problem is if something asks what is the maximum mass, that is a giveaway. And it's also a giveaway if they give you information about both of the starting materials. So we're going to say, all right, I want to know what the maximum mass of BaSO4 is when I mix 37.5 milliliters of 0.44 molar magnesium sulfate solution. Now I'm going to turn my milliliters into liters here for this one. And then I'm going to mix it with 46.8 milliliters. Again, I'm going to change that into liters of 0.01 molar barium chloride. Now I have information about both of my starting materials. That means I'm limiting in excess. So step 2 was to put everything you know into moles. So what I'm going to do is I'm going to take, for moles of MgSO4, I'm going to take my 0.44, I'm going to multiply it by 0.0375. When I do that, I'm going to get an answer of 0.017 moles of MgSO4. I'm also going to get my moles of barium chloride, so I'm going to take its molarity times its volume in liters again. Remember, we're using the solutions one over here. And then I'm going to get an answer. Now, because it is a 1-to-1 ratio, that means I need both the same amount of both of these. If I had 10 of these, I'd need 10 of these. If I had 20 of these, I'd need 20 of these. So if I have 0.017 moles of this, I need 0.017 moles of my barium chloride. Do I have 0.017 moles of this? The answer to that is no. The answer is I actually have less than I need, which makes this one my limiting. Okay. Now, the third part of the reaction is saying that you should now use your limiting to finish the problem. So what I'm going to say is that this is my limiting. This is a 1-to-1. This is my target. I have a 1-to-1 ratio, so it's also how many moles I have of my BaSO4, and that's what's the maximum mass of BaSO4. But I wanted to know mass, so I put it over the formula weight of 1 barium, 1 sulfur, and 4 oxygens. Gets me 233. When I multiply that together, I get 1.1 grams of BaSO4. Now, for question number 2, it is already balanced. I suggest that you take a look at the question and see if you can answer it and pause the program. Good, so I have a 16-to-1-to-8 balance, and it says that I have 12 grams of silver and 12 grams of S8, and I want to know what mass of silver sulfide I can make. So my question is, if I have 12 grams of each, I've got to put each into moles. These are now both solids, so I should be thinking that I'm going to use this equation. And I'm going to say moles for silver. I'm going to take 108 as my formula weight, 12 divided by 108. This is going to be 0.11 moles of silver. And for my moles of S8, I'm going to 12 divided by 256 because I need 8 S's. And then I get 0.047 moles of S8. Now here comes the hard part, identifying which is my limiting and which is my excess. You can cover up either way. You can do either one. I personally like to multiply. I like to say this is a 1 to 16 ratio. So I need 16 times the amount of this as I have of that. So I'm going to cover up this number, and I'm going to say this is a 1 to 16 ratio. So if I multiply this number by 16, do that in your calculator, what do you get? You should get 0.7 moles of silver. That's what I need. Now let's take a look. This is a hypothetical number here. This is not a real number. Do I have 0.75 moles of silver? I do not. Do I have more or less? I have less than I need, so this is my limiting. Now, if you can figure this out from here, I suggest you pause the program and try to figure out the rest yourself. All right, so I have my 0.11 moles of my silver, and the question here is how much silver sulfide will I have? So what I'm going to do is I need to go from silver to silver sulfide. So I'm going to go 16 to 8, which is just like a 2 to 1 ratio if I divide both by 8. So I'm going to divide this by 2. Now I get 0.055 moles of Ag2S, but the question though wants mass. So 2 silvers, 1 sulfur, gives me a formula of 248, multiply both of those, I get 13.64 grams of Ag2S. All right, I would pause the program now, see if you can't balance number 3, and give me the answer. All right, so first to balance, let's drop a 2 here and drop a 2 here. Also, the question says, what mass of PBI, so this is my target, I want to know how many grams of PBI can be made when I have 0.015 liters of lead nitrate, the molarity is 0.1 molar, reading the information out of the problem, and then I have 21 milliliters of a 0.1 molar sodium iodide solution. So you're looking at here, how am I going to get both these solutions into moles? I'm going to use the solutions formula. So I'm going to say for lead nitrate, I am going to multiply 0.1 times 0.051. That gives me 0.0051 moles of my lead nitrate. And I'm going to do my 0.1 times 0.021 to get me my moles of sodium iodide. Now again, I like to multiply. You do not have to multiply. You can do whatever you want. You can cover whichever one. Follow the ratio. But I know that this is a 1 to 2. 1 to 2 coefficient. So I need twice as much sodium iodide as I do lead nitrate. So I'm going to cover up my sodium iodide, and I'm going to say I need twice as much. This is a 1 to 2. I need twice as much. So when I multiply my lead nitrate by 2, I get on my calculator that I need 0.003 moles of NaI. Let's look behind and see what we have. Do I have 0.003? No, I have 0.002, which is less than I need, theoretically. So this is actually going to be my limiting. Okay, awesome. Some people look at this and say, hey, this is smaller, so that's limiting. No, this is actually my limiting because I need twice as much, and I don't exactly have twice as much. So now I'm going to move on here, and I'm going to say, all right, that's how many moles of my limiting. Let's answer the question. It wants to know how many grams of PBI. So this is a 2 to 1 ratio, so I'm going to divide it by 2. And I'm going to set this equal to, now I put 0.11 moles of PBI. If you do 1 lead, 2 iodines, you get this X over 461, which is a nice big formula weight. And you're looking at 0.51 grams of lead iodide. Let's have you flip this paper over so you can't pause the program and do the next one by yourself. Okay. All right, so if we're going to balance this, we have a 2 here, and we have a 2 here and here. It says, consider the following reaction. What mass of Na2SO4? So I'm looking for grams of that bad boy. can be prepared if I have 29.3 milliliters of a 0.5 molar solution. Now I left this in milliliters, so you might want to not get tripped up there. And I have 17.8 grams of sodium bicarbonate. If you're still not getting this, I would say pause the program now and make sure you drop each of these into moles. The way I'm going to do that is I'm going to do 0.5 times 0.0293, and I'm going to get 0.015 moles of H2SO4. I'm going to take my mass, divide it by its formula weight, which is 84, and I'm going to get 0.21 moles of NaHCO3. Now, got to stop and decide what's my limiting, what's my excess. Again, I like to multiply, so I'm going to cover this up, and I'm going to say this is a 1 to 2 ratio. 1 to 2, I need twice as much. So I'm going to take this number, I'm going to multiply it by 2 and figure out in theory how much sodium bicarbonate I should need. So when I multiply this in 2, I should have 0.03 moles of sodium bicarbonate. Let's take a look. Do I have 0.03? No, I actually have a whole lot more. 0.2 is way bigger than 0.03, so this is a lot more than I need. So this is my excess, and that means that this is my limiting. Okay, so again, if that's all you need, pause the program so you can't figure out where you're headed. So I'm going to take my limiting factor, and I'm going to go to my target from here to here. That's a 1 to 1 ratio. So now I have 0.015 moles of sodium sulfate. The question though is what mass of sodium sulfate. So I'm going to multiply it by 142, which is the formula weight, and I get 213 grams. All right, I would say pause the program and see if you can't figure out number 5. All right, so again, check and see if it's balanced. It's not. This one was a little more tricky on the balance. We got a 2, we got a 6, we got a 2, and we got a 3. The question says, consider the following chemical reaction. What mass of aluminum chloride can be made with 12.1 grams of aluminum? I'm going to react that with 38 milliliters of a 0.25 molar hydrochloric acid solution. So what I'm going to do is I'm going to find moles of aluminum by dividing it by its own formula weight, which is 27. And then I'm going to get 0.45 moles of aluminum. I'm going to put this into liters, multiply it by its molarity for moles of my hydrochloric acid. And then we're going to take a look here. I personally, like I said, I like to, let's erase this a little further, get my point there. I personally like to multiply. You could do it the other way, but I'm going to cover this number up because this is getting bigger here. So this is a 1 to 3, 2 to 6, 1 to 3, same thing. So I'm going to multiply this number by 3. When you multiply 0.45 times 3, I get 1.35 moles of HCl. That's what I should have. That's what I should have. Let's take a look. Do I have 1.53? I absolutely do not. I actually have less. I have too little of what I need. So this is my limiting. And then that's going to control my stoichiometry. So now I have 0.095 moles of HCl. I'm going from my limiting to my target. That's a 6 to 2, which is actually the same as a 3 to 1. So I'm going to divide this number by 3. That's going to get me 0.032 moles of AgCl3. And again, it wants mass. So I'm going to put X over 132. And then I'm going to get a number of 4.22 grams of AgCl3. Good. Now the ones down here are really simple. They're kind of just asking you what you got here. For instance, I want to know how many grams of this I could make. I'd like to know how many grams of that I can make, and you're given information about both of them. So my suggestion is to pause the program, see if you can't balance them and figure them out. All right, so this first one's trying to be a little irrational for you. This is already in moles, and this is given in grams. So what I'm going to do is I'm going to take my 17 grams, and I'm going to divide it by 74, which is the formula weight of KCl, and I'm going to get 0.23 moles of KCl. Now, this is already balanced as written. I think we forgot to say that, but it is already balanced. So if I have 0.45 moles of this, I should have 0.45 moles of this. Do I? That is a no. I actually have less of this, so I'm going to box this up. This is my limiting. So I'm going to go from here to my target, and that is a 1-to-1 ratio. So if I have 0.23 moles of that, I also have 0.23 moles of my target, which is AgCl. And it asks for mass. I'm going to multiply that times 143. I'm going to write excellent. Because I'm going to have 1 Ag, 1 Cl, and the number that you're going to get is 32.89 grams of AgCl. All right, pause the program, see if you can't figure out B. All right, let's balance it up. I need a 2 there, and I need a 2 over here. I don't know why my numbers are falling down here. 2 and 2. All right, take everything you have, put it into moles. We already have moles here. So let's take a look. This is a 2-to-1 ratio. So I need half as much of this as I have of that. Again, I personally like to double. So I'm going to cover this number up. And this is a 1-to-2 ratio. So I need twice as much. So I'm going to take this number of moles, I'm going to multiply it by 2. And when I do that, I get 0.64 moles of NaOH. Let's take a look. Do I have 0.64? Absolutely not. I do not have enough. So therefore, this is my limiting. And that's what I'm going to use to do my stoichiometry. So now I have 0.22 moles of NaOH as my limiting. I want to know about my grams of sodium sulfate. So that is a 2-to-1 ratio. So I'm going to divide by 2. 0.11 moles of Na2SO4, and the question asks me for grams. So I'm going to multiply that by the formula weight, which is 142, and you get 15.62 grams of sodium sulfate. All right, we got the last one here. I suggest you pause the program, check and see if it's balanced. All right, so it is balanced as written. Again, we're giving some solutions, so we got to make sure that we drop these into moles by multiplying the milliliters by the molarity. So to get moles of BaCl2, I'm going to take 0.1 and I'm going to multiply this that's been converted into liters. I'm going to get 0.0052 moles of BaCl2. Then for my moles of K2SO4, do the same thing. Take the volume in liters, multiply it by the molarity. Now, this is a 1-to-1 ratio. So if I have 0.0052 moles of BaCl2, I should have 0.0052 moles of the K2SO4, and I do not. So therefore, this is less than I need. So this is my limiting. I'm going to take that number, and I'm going to say it's another 1-to-1 ratio to my target. Oh, just kidding. Not balanced as written. My apologies. Sorry. So this is a 1-to-2 ratio because I'm from here to here. Way to mess it up at the end here. My apologies. We didn't balance it. So this is a 1-to-2 ratio. So what I'm going to do, I'm going to multiply it by 2. And then so I get 0.072 moles of KCl. It wants the mass. So I'm going to set it equal to x over the formula weight of itself. And you get 0.53 grams of KCl. Hopefully I didn't mess you up on this last one. I just see what happens when you don't balance your equations. So hope you're doing good. Let me know. Bring any questions you have into class.